Welcome to this video on mains electricity. We will cover how electricity reaches your home, how it functions, and the safety measures you need to know for your GCSE Physics revision. Mains electricity is the supply delivered to our homes and businesses via the national grid. In the UK, it is provided AC alternating current at a voltage of around 230 volts and a frequency of 50 Hz. Electricity is generated at power stations and transmitted through the national grid's vast network of cables and transformers. It is stepped down to a safe, usable voltage of 230 volts before reaching your home. Mains electricity uses alternating current, or AC. Unlike direct current, the direction of AC reverses 50 times every second. This makes it efficient for transmission over long distances and allows for easy voltage adjustment. In contrast, direct current, or DC, flows in only one direction. It is commonly supplied by batteries and cells, where the current flows steadily from the negative terminal to the positive terminal without reversing. A quick summary of the differences. AC is for mains and reverses direction, while DC is for batteries and flows in one direction. Remember this distinction, as it is a common topic in exam questions. Key numbers for the UK mains supply include 230 volts for voltage and 50 Hz for frequency. Also remember that a standard plug contains 3 different wires, each with a specific purpose. Every UK 3-pin plug uses 3 wires. Understanding the color and function of these wires is vital for both your physics exam and your personal electrical safety. The brown live wire is the most dangerous. It carries the full 230 volt supply. Never touch it, as it remains at 230 volts even when a switch is off, provided the switch is on the neutral side. The blue neutral wire is at or near 0 volts. It completes the circuit by providing a return path for the current. While it is safer than the live wire, it should still be treated with caution. The green and yellow striped earth wire is a safety feature. It normally carries no current but provides a low resistance path to the ground during a fault, causing the fuse to blow and cutting off the power. Here's a quick summary for your revision. Live is brown, neutral is blue, and earth is green and yellow. Learn these wire colors by heart for your exams. A fuse is a critical safety device found inside a plug. It is connected in series with the live wire and contains a thin piece of wire that melts if the current becomes too high, protecting against fire. If a fault occurs, excess current causes the fuse wire to heat up and melt. This breaks the circuit, stopping the flow of electricity. Remember, once a fuse blows, it must be replaced as it cannot be reset. To choose the right fuse, use the formula. Power divided by voltage equals current. Always select a fuse rating just above the operating current of your appliance to ensure it is protected safely. Circuit breakers are an automatic alternative to fuses. They detect excess current and automatically disconnect the circuit. Unlike fuses, they can be reset once the fault is fixed, offering faster and more reliable protection. While fuses are cheap and common in plugs, they must be replaced after blowing. Circuit breakers use an electromagnetic switch that can be reset, making them a reusable and modern safety standard in consumer units. An RCCB, or residual current circuit breaker, is an enhanced safety device. It detects tiny imbalances between the live and neutral wires, which could indicate electricity is passing through a person. It acts in milliseconds to prevent electrocution. Double insulation is a safety feature, where live parts are protected by 2 layers of insulating material. These devices have no exposed metal, so they don't need an earth wire. Look for the double square symbol on appliances like hair dryers. Now let's cover electrical safety in the home. Electricity is incredibly useful, but also potentially lethal. Understanding how to avoid hazards is essential for your exam and for staying safe in real life. Damaged cables are a major fire and shock risk. When insulation is cut or frayed, live conductors can become exposed. This can cause short circuits, start fires, or deliver a dangerous electric shock to anyone who touches the wire. Never overload electrical sockets. Plugging too many appliances into one socket, especially with adapters, can exceed the safe current limit. This causes the cables to overheat, creating a significant fire hazard. Water and electricity are a deadly combination. Water reduces your body's resistance, making shocks much more severe. Keep appliances away from sinks. Never touch switches with wet hands. And remember that standard sockets are prohibited in bathrooms. Always switch off the power before doing any repairs. Even if a switch is off, internal wires may still be live. A professional electrician will isolate the circuit at the consumer unit to prevent a potentially fatal electric shock. Electrical current affects the body by interfering with nervous system signals and heart rhythm. High currents can cause muscle paralysis, severe internal or external burns, and even cardiac arrest. This is why electrical safety is so vital. To summarize safety, inspect cables regularly, Never overload sockets. Always isolate the power supply before working on circuits, and strictly avoid water when handling electrical equipment. Moving on to power and energy. Understanding how electrical energy is transferred is a key part of your physics course. These calculations link directly to concepts of current, voltage, and time. Electrical power is the rate at which energy is transferred, measured in watts. Use the equations power equals current times voltage, or current squared times resistance. For example, a 9-amp kettle on a 230-volt supply uses over 2 kilowatts. Electrical energy is calculated by multiplying power by time. Energy companies bill us in kilowatt hours, representing the energy used by a 1 kilowatt appliance running for 1 hour. This determines your cost of electricity. To calculate the correct fuse for any appliance, divide its power rating by the 230-volt mains supply. Choose the fuse with the lowest standard rating that is just above that operating current to ensure it provides effective protection. Now, we will explore the national grid. This is the expansive network that transmits electrical energy from power stations to homes and businesses throughout the UK, using high voltages to minimize energy loss. The national grid relies on transformers. Step-up transformers increase the voltage for efficient long-distance transport, while step-down transformers reduce it to a safe 230 volts for use in your home. Why use high voltage? By increasing voltage, we reduce the current for the same amount of power. Since heat loss in cables depends on the square of the current, higher voltage significantly improves efficiency. For your exams, recall the 3 wires. The brown live wire carries 230 volts. The blue neutral wire completes the circuit at 0 volts, and the green and yellow earth wire provides essential safety. Avoid common mistakes. Mains electricity is AC, not DC. Also, remember that the earth wire only carries current during a fault. Use the mnemonic "brown is the boss" to remember the live wire carries the high voltage. More traps to watch for. Always choose the fuse rating just above the operating current. Also remember that double insulated appliances do not require an earth wire, and unlike fuses, circuit breakers can be reset. Let's practice. For an 1150-watt hairdryer, the current is 5 amps. A 3-amp fuse would blow, so you must select the next standard rating, which is 13 amps. Remember the difference. Alternating current reverses direction, like the mains supply, whereas direct current flows in one direction, like the power from a battery or cell. If a fault makes a metal casing live, the earth wire provides a low resistance path, causing a surge of current that blows the fuse and disconnects the appliance, protecting you from shock. To recap, keep in mind the differences between AC and DC, the roles of the 3 wires, safety devices like fuses and breakers, and the importance of double insulation and electrical safety rules. You have covered the key concepts for the national grid and mains electricity. Review these points, practice your calculations, and you will be well prepared for your exam. Good luck!